Good morning, everyone. Welcome to Guru Brahma classes for JE and NEET. So, today in this session, we are speaking about enthalpy. What is that? Enthalpy. What is meant by enthalpy? Enthalpy is the total heat content of a system, at constant pressure and temperature. Generally, when the temperature is changed, heat content will be changed. So mainly we are speaking about here constant pressure. So the total heat content of a system at constant pressure and temperature is called as enthalpy, right? So enthalpy is a state function. State function means it depends upon the state defining properties like pressure, volume, temperature, number of moles. So it depends upon initial and final state of the system. So it is a state function. Already we have discussed. And it is an extensive property. Extensive property means it depends upon the quantity of matter present in the system. If quantity of matter increases, enthalpy increases. If quantity of matter decreases, enthalpy decreases. When it is an extensive property, it is additive in nature. So enthalpies can be added. Enthalpies can be subtracted. Okay. So it is calculated as sum of internal energy and product of pressure and volume. Right? So we have a formula that H is equal to U plus PV. So what is H? Enthalpy. What is U? Internal energy. P pressure and V is volume. Right? Now, what is the relation between delta H and delta U? Generally, it will be asked. First of all, we shall discuss here what will be delta H. Normally, we have discussed that enthalpy is additive in nature. So, delta H, delta means change. Delta means change. That is equal to H final minus H initial. H final minus H initial, or you can also write it as H2 minus H1. So what is this? The change in the enthalpy or change in the heat content of a system at constant pressure. For example, let us take a system. This is a system. So some gas is enclosed in this cylinder, right? So here let P be external pressure, P be external pressure, and which is equal to constant. What is that? Which is equal to constant. At this constant pressure, let Q amount of heat energy is absorbed by the system. As heat is absorbed by the system, it is taken as positive, and it is absorbed at constant pressure, so we mention it as QP. Mention it as a QP. And we know that formula. What is that work done formula? Work done is equal to minus P external into V final minus V initial, right? Okay. So work done formula is minus P external into V final minus V initial, right? From the first law of thermodynamics, what did we understand from first law of thermodynamics? We can say that delta U is equal to Q plus W. Okay. Then what will be Q? Q is equal to delta U minus W, right? So here we are speaking about at constant pressure. So QP is equal to delta U is U final minus U initial minus work done is minus P into V final minus V initial. Then QP is equal to U final minus U initial. Here again we will have work done is minus P, right? So then what do we have? Minus of minus P. So minus of minus gives you plus P V final minus V initial. And that is equal to U final minus U initial plus PV final minus PV initial. So this can be rewritten as U final plus PV final minus U initial plus PV initial. Okay, PV initial. Then what do you get? U plus PV. Now only we have seen from the statement given here U plus PV, U plus PV, work done is equal to PV now. So U plus PV here, U plus PV here you see U plus PV is equal to H. U plus PV is equal to H. So now let us write that. So QP is equal to U final plus PV final is equal to H final minus U initial plus PV initial is equal to H initial. So QP is equal to delta H. Change in the enthalpy is nothing but it is the heat, amount of heat absorbed at constant pressure. Absorbed at constant pressure. So QP is equal to delta H. Okay. QP is equal to delta H. Now, what is the relation between delta H and delta U? Now only we have seen that it is right. So delta H is equal to PV. Then delta H, your delta H is equal to delta PV, right? So delta H is equal to delta into PV is equal to P delta V plus V delta P, right? So we have formula delta H is equal to U plus PV. Delta H is equal to, see, H is equal to what? H is equal to U plus PV, right? Then delta H is equal to delta U plus delta PV. Okay. Then that is equal to delta U plus delta into PV gives you P delta V plus V delta P. Then that is equal to delta U plus, here we are mentioning that the reaction is happening at constant pressure. So delta P is equal to 0. When delta P is equal to 0, V into delta P will be equal to 0. So P delta V. So delta H. So the relation between delta H and delta U is delta H is equal to delta U plus P delta V. So this is one relation which describes this is one mathematical representation which describes the relation between delta H and delta U. Okay. So here, when you take a gas, so the difference between delta H and delta U is not significant for systems containing solids or liquids, only solids or liquids. But the difference, however, becomes significant when the gases are involved. Which are involved? When gases are involved, the difference between delta H and delta U becomes significant. So when gases are involved, the difference between delta H and delta U are significant. So when you take, for example, ideal gas, what is ideal gas equation? PV is equal to nRT. PV is equal to nRT. So if you differentiate delta PV is equal to delta nRT, right? Delta PV is equal to delta nRT. So delta PV can be written as P delta V plus V delta P is equal to delta nRT plus nR delta T. R is constant. Who can change? Number of moles changes, temperature can change. Already we have seen that P is constant. So P is constant, pressure is constant. When pressure is constant, delta P is equal to 0. T is also constant at constant temperature because most of the reactions occurs at a constant temperature. So delta T is also equal to 0. Then you can write it as P delta V is equal to delta N RT. So for this delta N, we write delta N G also because it is applicable for whom? Gases, right? So P delta V is equal to delta N RT, right? So for a chemical reaction, involving gases, delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. So here what is NP? NP is number of moles of gaseous products which are in gaseous state, and NR is number of moles of gaseous reactants. Okay, gaseous reactants. So if we can calculate delta N, then it is easy to find the relation between delta H and delta U, right? So that is the relation between delta H and delta U. What is that? Delta H is equal to delta U plus P delta V. And if you apply equation 2 in equation 1, so let it be equation 1. So substitute equation 2 in equation 1. Equation 2 in 1, then what do we get? delta H is equal to delta U plus delta NGR. So this formula is very important. Based on this formula, we are asked questions in competitive exams. Right? Next, here, so for finite change, we use delta. For infinite change, we use D. Right? So delta H is equal to delta U plus P delta V for exothermic reaction. So delta H for a chemical reaction, for a chemical reaction, reactants gives rise to products, then delta H is given by HP minus HR. Okay, HP minus HR. So for exothermic reactions, what is that? Exothermic reaction. HR will be greater than HP. That means enthalpy of reactants will be greater than enthalpy of products. That means reactant plus some energy gives rise to products. Okay, what is that? Exothermic reaction means reactant is product plus energy. See, this is the exothermic reaction. That means reactant is forming product by releasing some energy. So reactant energy is equal to product plus some energy. So reactant energy is greater than product energy. So then delta H is equal to HP minus HR. So reactant energy is greater, product energy is that. So we get it as negative value because reactant energy is greater than product energy. So delta H. When you come to endothermic reactions, what is that? Endothermic reaction. For endothermic reaction, reactant plus some energy gives rise to product. So reactant is having some energy plus it is added with some energy so that product is formed. So product energy will be greater than reactant energy. So delta H is equal to HP minus HR. As product energy is greater, we get it as a positive. For endothermic reaction, delta H is positive. For exothermic reaction, delta H is a negative. Okay. So let us see the relation between delta H and delta U. Already we have discussed this, right? Delta H is equal to delta U plus delta nRT. Another formula also we have derived, and that is delta H is equal to delta U plus P delta V. Okay. We have also derived that QP is equal to delta H. So what is delta N? Number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles of gaseous products minus number of moles of gaseous reactants. So R is universal gas constant, T absolute temperature, these all things you know. Okay. So for example, let us take equation which involves gases. For example, H2 gas plus I2 gas state gives rise to 2HI gas state. What is delta N? Delta N is equal to number of moles of gaseous products minus number of moles of gaseous reactants here delta N2 minus reactants 1 plus 1, 2, that is equal to 0. In this case, delta U, delta H, formula is delta H is equal to delta U plus delta NR. Delta N is 0. So delta H is equal to delta U. So when is this condition? Delta N is equal to 0. Let us go with another equation. N2 gaseous state plus 3H2 in gaseous state gives rise to 2NH3 in gaseous state. What will be delta N is equal to 2 minus 1 plus 3, that is equal to 2 minus 4 is equal to minus 2. So delta N is less than 0. Delta N is less than 0. Then delta H is equal to delta U plus minus 2 RT. So then what you write? Delta H is equal to delta U plus 2 RT. Okay. So delta H is equal to delta U plus something. So delta H will be greater than delta U. When is this condition? When is this condition? The condition is that delta N is less than 0. When delta N is less than 0, then so let us see when delta N is less than 0, then what did we get? Delta U is equal to delta H plus this 2RT comes this side, 2RT, then delta U is equal to delta H plus something. Then what you write? Delta U will be greater than delta H, right? So delta U, delta E is nothing but U. Okay. So delta E is greater than delta H when number of moles is less than 0. When number of moles is, when delta N is equal to 0, delta H is equal to delta. Okay. Next, let us go with one more reaction. PCl5 gives rise to gaseous state PCl3 plus Cl2. In this reaction, let us see delta N is equal to 1 plus 1, 2 minus reactant 1, that is equal to 1. That means delta N is greater than 0. When delta N is greater than 0, delta H is equal to delta U plus 1 RT. So delta H is equal to delta U plus something. That means delta H is greater than delta U. Okay. So when is this condition? When delta N is greater than 0. When delta N is greater than 0. Right? So that is the relation between delta H and delta U. Next, let us solve some questions PYQ. So this question is given in J-Mains 2024. Okay. So the heat of combustion of solid benzoic acid at constant volume, heat of combustion, right? So let us see delta CH, heat of combustion, delta H. Overall, we are mentioning it as delta H. So delta H of benzoic acid is given as minus 321.30 kilojoules. Okay. So enthalpy is generally always calculated per mole. It is calculated per mole. Delta H enthalpies are always calculated per mole, per 1 mole. So simply you can write kilojoule per mole, right? Then the heat of combustion at constant So this is given at constant volume. Heat of combustion at constant volume it is given. So volume means what we have to take delta U. What is that? Delta U. Then heat of combustion at constant pressure is given. Pressure is asked. So then delta H is equal to how much? And we know the formula delta H is equal to delta U plus delta nRT. Okay. So then if you are able to calculate delta N, then it is easy. To calculate delta N, first of all, we need to know the reaction, heat of combustion reaction of benzoic acid. What is the formula of benzoic acid? C6H5COOH. So this is combusted. Combusted means reacted with the oxygen to form CO2 plus H2. So we need to balance this equation. So there are 6 carbon atoms. So 6 carbon atoms, 6 CO2. There are 6 hydrogens. So 3 into 2 gives you. Already in the reactant there are 2 oxygens. Right? Here 6 to 12 plus 3. On the product side we have 15 oxygens. On the reactant side already we have 2 oxygens. Then here we want 13 oxygen atoms. 13 oxygen atoms can be written as 6.5. So 6.5 into 2 gives you 13. 13 plus 2, 15. Reactant side 15 oxygens. Product side also 15 oxygens. So it is already mentioned that it is solid. So oxygen is gaseous state. Carbon dioxide is in gaseous state. Water will be in liquid state. Then what will be delta Ng? That is equal to number of moles of gaseous products minus number of moles of gaseous reactants, that is equal to 6 minus 6.5, that is equal to 0.5. Right? Then let us calculate delta H. So delta H is equal to delta U. Delta U is already given minus 321.30 plus delta N. Delta N, what did we get? 6 minus 6.5, what do we get? It is minus 0.5. So minus 0.5 RT. 0.5 RT. So that is equal to minus 321.30 minus 0.5 into R into temperature already given here 27 degrees centigrade. If you convert 27 degrees centigrade into Kelvin, then we get 300 Kelvin. That is equal to minus 321.30 minus 0.5 into 300 gives you 150 R. So this representation, this is delta H. So here asked is the delta H at constant pressure minus 321.30 minus XR. So minus 321.30 minus, what did we get? 150 R. So the answer will be what? 150. Okay, X is equal to what? 150. Understood? Next, coming to another PYQ which is given in 2024 JEE-Main. What is that question? Second question, enthalpy of vaporization for water is, so delta H. So vaporization for water is equal to plus 40.79 kilojoule per mole given at 1 bar and 100 degrees centigrade. Temperature is equal to 373 Kelvin. Change in internal energy for this vaporization at the same. So change in internal energy is given by delta U. Delta U is asked. So per mole, it is calculated per mole. So water in liquid state is converted into water in gaseous state. Here delta N is equal to 1 minus 0, that is equal to 1. Okay. Then delta H, delta U is equal to, we know that delta H minus delta nRT. delta H is 40.79 minus of nRT 1 into R value already given, right? 8.314, 8.3 is given, that's it, 8.3. But in the question we are having kilojoule per mole, so we have to take into 10 power minus 3 kilojoule per mole per Kelvin into temperature 373. Okay, so then delta U will be, what do we get? 38 kilojoule per mole. So 40 minus this, if you calculate this, then what do you get? 38 kilojoule per mole. So the answer is 38. Answer is 38. Hope so you understood it very well. Thanks for watching up to end of the video. If you like the video, please like, share and subscribe. We shall meet in the next session. Thank you very much.